네, 안녕하세요. 김원장 인사이트입니다. 오늘은 일론 머스크가 유명 유튜브 채널 올인 팟캐스트에 영상으로 출연하여 출연자들과 도지에 대해서의 일과 옵티머스 로봇 생산에 대한 어려움 및 목표, 그리고 AI 칩과 스타링크 스마트폰의 지향점 등에 대해서 상세한 대화를 나눴습니다. 올인 팟캐스트는 유명 투자가 기업가 4명이 진행하는 토크형 팟캐스트로 진행자들은 챔스 팔리하피티아, 제이슨 칼라카니스, 데이비드 sak스, 데이비드 프리드버그가 진행합니다. 경제, 기술, 인공지능, 정치, 투자, 트렌드 등 깊이 있게 분석하는 걸로 유명한 채널입니다. 이번 영상에서는 일론 머스크가 출연하여 XAI, AI 산업의 확장, 효율성 부서에서의 배운 점, 옵티머스 로봇, 스타링크 스마트폰 등 최신 이슈에 대해 그동안 듣지 못한 개발의 어려움과 진행 방향 등에 대해 자세히 설명했습니다. 저는 자막 작업을 하면서 몇 번 봤는데 매우 놀랄만한 내용들이 가득 차 있습니다. 여러분들도 본 영상을 끝까지 보시기를 권합니다. 지금부터 본 영상을 저와 함께 보시겠습니다.
Elon Musk.
All right. Where are you?
Alto.
You're in Palo Alto and
Yeah.
not Washington, D.C.
I'm at Tesla Global Engineering Headquarters in Palo Alto.
Yeah. So no more Washington, D.C. You're back at work. You're focused. Yeah?
Yeah, I haven't been to DC since May.
Okay.
That was a hell of a side quest.
That was a good sign. Any lessons from your time in Washington, D.C.?
The government is basically unfixable.
Elon, only.
I applaud David's noble efforts in this. It's good to have talented people in the administration, but at the end of the day, if you look at our national debt, which is insanely high, the interest payments exceed the Defense Department. War Department budget, and they keep rising. So, if AI and robots don't solve our national debt, we're toast.
Which is a great segue. Optimus is, I think, going to be the greatest product in the history of humanity. What's the progress like, and how many of your cycles are going specifically to Optimus? What's the timeline? I think you're on version 3, maybe 4. Tell us everything.
Yeah, no, everything would take a long time.
We've got time.
We're finalizing the design of Optimus version 3, and that really is going to be a very remarkable robot. It will have essentially the manual dexterity of a human, so meaning a very complex hand. An AI mind that can navigate and comprehend reality, and it will be made in very high volume. Those are the three things that are missing. Like if you see any other robotics company, they're missing those three things. Those are the three really hard things. I spend actually at this point, it might be more of my mental cycles than anything else, any other single thing on Optimus. That's solving for real-world AI, all of the electromechanical issues of Optimus, the supply chain and production challenges of it, because there is no supply chain that exists for humanoid robots. So we have to recreate it from scratch, and which requires doing a lot of vertical integration. None of the actuators in Optimus are available from an existing supply chain. But I think it is accurate to say that if successful, Optimus will be the biggest product ever.
And the cost of it at scale, $20,000, $30,000, $40,000 a robot. What do you think the first wave of them will cost? And when will we be able to buy one to work on the ranch?
I think that the marginal cost of production, once you hit 1 million units per year, is probably around the $20,000 range. It sort of depends on how much you spend on the AI chip in the robot, and you need to achieve a lot of efficiencies in the actuators. There are 26 actuators per arm, like 26 electric, like motors, gearboxes, and power electronics. But the AI chip will be pretty expensive. Like that might be like $5,000 or $6,000 of the bill of materials, maybe more. But I think at volume, at 1 million units a year, the production cost is probably on the order of $20,000, maybe 25, something like that. And price will be as a function of demand.
Elon, can you maybe explain to everybody why the hand is so important to get right, and why, the actuator design is so unique, and, why it's so difficult, why nobody makes it, and why you have to start there almost to build the rest of the robot properly?
Well, it turns out the human hands are they've evolved to be this incredibly sophisticated machine. Like your hand is actually a remarkable thing. Look closely at your hands, and think of all the things you can do with your hands, which is a lot.
I can think of many things. Yeah, I was just thinking about something.
Your hands are a very versatile instrument.
Yeah. You can give a high five.
Very versatile. You can swing a baseball bat. You can thread needles. You can put thread in a needle. You can play the piano with violin. You could disassemble or assemble a car. The hands are incredibly versatile instruments, and most of the muscles of the hand are actually in the forearm. So your hand is kind of like it's like a puppet. Like it's mostly a puppet. The muscles are coming from the forearm, and they're pulling the tendons, which are also human tendon designs or human tendon evolution is incredibly good. So you've got this web of tendons. You've got I think the human hand has something like, depending on how you count it, 27 or 28 degrees of freedom per in the hand. It's amazing. So in order to create a robot that can be a generalized humanoid, you must solve the hands problem.
We had Ari.
It's got hands, needs hands.
Yeah.
And so is it like when you were first building Tesla, where the supply chain doesn't exist and now you have to go out and find folks to work with and build all this vertical integration, get support? Is it literally like it's just nowhere to be found and you're going to have to build all of this stuff up?
Yes, we could not actually buy the actuators for any amount of money. They simply didn't exist, even though there are, 10, 20,000 electric motors out there of various sizes and shapes. We've had to design every electric motor, gearbox, and the controlling electronics from scratch, basically from physics first principles.
The good news is you've got a lot of experience with factories over the last couple of decades. So how challenging is this versus Cybertruck, Model Y,
Model X,
Gigafactory, the Fabergé egg known as the Model X? Yeah.
Right. It's harder than any of those things.
Okay.
Yeah.
Much harder? Significantly, yeah.
Starship?
Yes. Well,
Harder
at
than
least
Starship?
No, not hard. Starship's harder. Starship's harder.
So somewhere between a Model X and a Starship.
Yeah.
What's harder, the hardware or the software?
Right now, we're struggling with the final design of the hardware. Like I said, it's really primarily the hand. Not to just dismiss the rest of the robot. The rest of it's also important, but the hands inclusive of the forearm are a majority of the engineering difficulty of the entire robot.
And then let's assume you get past the hardware challenges. How much do you sort of get for free based on all the progress that's happening with LLMs? Will consumers just be able to interact with this, talk to the robot, ask
Oh,
it
yeah.
to do things, it'll understand, and sort
Oh,
of,
yeah.
yeah.
Yeah, no problem.
You're spending a lot of time with Annie, I noticed, online.
Not that long. Maybe I went a little over the top promoting Grok Imagine, but
Well, but in all seriousness, those characters and these robots, that seems to be, like maybe they,
you could get the embodiments of Annie, I suppose.
yeah.
Why the human form factor, Elon? You could make something that's maybe better than a human, or maybe simpler than a human to do specific tasks, and maybe better than a human to do more things than a human can do. How'd you decide to make it just like a human?
Well, if you wanted to do all the things that a human can do, it turns out you need a humanoid robot. So if you wanted to do a subset, that's much easier. But it turns out humans evolved to the shape and capabilities that we have for good reasons. There actually is there is like there's value to having 4 fingers and a thumb, and even the pinky actually is quite useful. Toes are much more a question mark, but the fingers.
Well, also humans have designed the world as well, so we designed it for us.
For us,
So
exactly.
if you can make a humanoid robot, it'll be immediately backwards compatible with what we built the world for.
Precisely.
Elon, there's
Yeah.
another part of the robot. So there's the LLMs, there's the actuation in the hands, but also there's the silicon that runs it. And there was, Dojo. I think you posted on X AI5 and AI6, and it just seemed like you were incredibly excited about the direction in which the silicon layer was also going. Can you tell us about that and what that is, and what are we building here? What is being built? Is it a complement to everything that exists in the world? Is it a potential long-term competitor? What is it?
Yeah, so at Tesla we basically had 2 different chip programs, one Dojo and one Dojo on the training side, and then what we call AI4, it's just our inference chip. The AI4 is currently shipping in all vehicles, and we're finalizing the design of AI5, which will be an immense jump from AI4. By some metrics, the improvement in AI5 will be 40 times better than AI4.
Wow.
So not 40%, 40 times. And this is because we work so closely at a very fine-grained level on the AI software and the AI hardware. So we know exactly where the limiting factors are. And so effectively the AI hardware and software teams are co-designing the chip.
So a 40x improvement in the silicon, I think then as everybody here in the audience experiences it, is that just almost like an order of magnitude increase in the quality of FSD and the safety that you experience as a Tesla driver, and then the quality of the robot? Like, where does it all manifest when you bring it up and actually get it into production?
Yeah, to be precise, the 40X is on, if you said like, compared to the worst limitation on AI4, which is running the softmax operation.
Yeah.
We currently have to run softmax in around 40 steps in emulation mode, whereas that'll just be done in a few steps natively in AI5. AI5 chip will also be easily handle mixed precision models, so you don't have it'll dynamically handle mixed precision. There's a bunch of sort of technical stuff that AI5 will do a lot better. In terms of nominal sort of raw compute, it's 8 times more compute, about 9 times more memory, roughly 5 times more memory bandwidth. But because we're addressing some core limitations in AI4, you multiply that by that 8x compute improvement by another 5x improvement because of optimization at a very fine-grained silicon level of things that are currently suboptimal in AI4, that's where you get the 40x improvement.
You had, oh, keep going.
So now that said, I am confident that the current chips, AI4 chips that are in the cars, will achieve self-driving safety that is at least 2 to 3 times that of human, and maybe even 10x. And the software that will be released for that is coming out over the next few months. So version 14 will be the biggest upgrade in Tesla software since version 12. We are increasing the parameter count by an order of magnitude. There's a lot of reinforcement learning that's been used. There's like, you can think of AI sort of as a way of compressing reality, and some of those compression steps were too lossy, and we addressed the lossiness in the compression steps. So these are all software updates that'll go out. So just over-the-air updates. Your car is going to feel like it is sentient by the end of the year.
Yeah. It feels that way already, to be honest. I saw in the trades that you spent about $17 billion on some spectrum, and so some couch change to enable your satellites and the Starlink network to connect directly with phones. What will that look like in a year or two? Are we going to drop our Verizon account and just expand our Starlink account? We're kind of hoping, because Verizon kind of sucks.
How many of you want a Starlink phone?
Who wants a Starlink phone? Is it technically
Elon,
possible?
I know you can't see it, but it's everyone.
Yeah, it's everyone.
All right, cool. So this is a kind of a long-term thing. It will allow SpaceX to deliver high bandwidth connectivity directly from the satellites to the phones. But there are hardware changes that need to happen in the phone. So since these frequencies are not supported in current phones, the chipset has to be modified to add these frequencies. And that probably is a 2-year time frame. So the phones that are able to use the spectrum that was acquired probably start shipping in around 2 years. And then we also need to build the satellites that are going to communicate on those frequencies. So in parallel, we're building the satellites and working with the handset makers to add these frequencies to the phones. And then the satellites and the phones will then handshake very well to achieve high bandwidth connectivity. But the net effect is that you should be able to watch videos anywhere on your phone.
Wow. And
From
it's going to be
Switch.
crazy.
And do these frequencies, would they work indoors inside buildings? You know, like your
Yes.
phone currently does? Okay.
And so will you be able to have
No,
basically
if you're in a building with a thick metal roof, then no. But
No, the same types of
normal
yeah.
normal homes, yes, yes.
Elon, is your vision for this that instead of having an AT&T account and then roaming when you're in the UK or you're in India, it's just we could have one direct deal with Starlink. It works all over the world, eventually, not today, but at some point. Is that the end goal? That basically we don't need a regional carrier. We have a global carrier, and that would be you.
That would be one of the options. To be clear, we're not going to put the other carriers out of business. They're still going to be around because they own a lot of spectrum. So there's, but yes, you should be able to have a Starlink like you have